Hi friends, welcome to Unacademy. Myself Bhavani. Students, as you all know, Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021 can subscribe the plus courses. In case if you want to join the plus courses, you can make use of this code Bhavani Live and you can get the maximum discount. There are different plans, student. We have a 12 months plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125. There are different batches. We have a comprehensive batch. We also have a Kannada batch. In case if you are comfortable in Kannada, you can join this batch. We also have the champions batch, which has begun from 15th of October. So you can enroll your name for these, any one of these batches, but make use of the code student Bhavani Live. You can go with different combinations also like PCM, PCMB, PCB. Okay, so whichever course is convenient and appropriate for you, you can join these batches. And students, in case if you haven't watched my YouTube session, kindly watch them, and whenever you like my class, press the like button and also press the bell icon so that you get further notification. Kindly check the description box also so that you get links for various special classes which I have already conducted under Unacademy. Students, you will be given class 11, and whenever you subscribe a plus course, the advantage is you will be given class 11 and class 12 topic that will be done in detail, daily practice paper, full length mock tests, and you will be having quizzes for analysis. So if you want to be a part of this one, kindly subscribe the Unacademy, and also do not forget to subscribe the YouTube channel also. Students, there are free practice tests that are available, so you can enroll your name for this and you can join and you can try. Always students, try to learn a particular topic, understand the concept very well. Once you understand the concept, and then you need to go with the questions. Do not straight away start with the question. Always it is essential that you understand a particular topic and then only you will go ahead with the questions. And learning also, student, first it should be NCERT textbook in detail. From the beginning you read it well, and then apart from that have any one comfortable book which you feel comfortable with, and then start working on the questions. Okay, so we will start today. We have been solving mock tests on coordination compound, and the students, when we work, once we complete a particular chapter, when we go with a question, try to solve as many as question, because when you solve questions, you will get the idea, student, different ideas by which you can arrive at the answer quickly. Okay, so we will go to the first question here now. The IUPAC name of the complex ion formed when gold dissolves in aqua regia is. Students, you can see a very interesting point here, that this question you are learning this equation, that is gold dissolving in aqua regia in P block element. But the question is asked under coordination compound. You can see the IUPAC name of the complex ion formed when gold dissolves in aqua regia. Now the four options given are tetrachloridoorate 1, dichloridoorate 3, tetrachloridoorate 3, or tetrachloridoorate 2. So you can see any one of the option whether it suits the answer. And as you can see here, student, the question has been already asked in CET 2014. So you can imagine from a chapter, different chapter, a complex is picked and its IUPAC name is asked. That is why I told you Learn the NCERT textbook in detail. Line to line study is a must. Okay. Now, what is aquaregia? What is aquaregia, student? When we take three parts of concentrated HCl and one part of concentrated HNO3, then it is called as aquaregia. Okay. Now we know that noble metals dissolve in aquaregia. So let us take gold. As you can see, Au, okay, H plus NO3 minus and Cl minus. Okay. You know, during this reaction you are going to get a complex AuCl4 minus, and you are going to get nitric oxide and water. So students, this will be the equation, isn't it? So the complex ion formed is this one. Now how do you name this complex ion? AuCl4 minus 1. Correct? So if you write X, Cl is minus 4, sum is equal to minus 1. That means you are going to get X as plus 3. So the name of this complex ion is tetrachlorido-orate, because it's a negative ion. So name should, metal name should end with 8. So tetrachlorido-orate 3. So answer is option C. Okay, I hope it is clear, students. Go to the next one. Titanium H2O6 2 plus is a 3D2 system. The value of crystal field stabilization energy decreases by. Students, we all know that there are 5 d orbitals. When they split, they will split as T2G and EG orbital. Okay, so T2G and EG orbital. Now you can see here, these energy orbitals are having lesser energy than the d orbital, whereas these d orbital, that is the EG orbital, has more energy than the d orbital. That means the question is, the crystal field stabilization energy decreases by. Decreases by means they are asking this amount. This is decreases by. From here to here it is increases by, isn't it? Therefore, since you have 3D2 system, you know that the electron will enter to T2G. So the configuration is T2G to EG0. Now the energy decrease means here, so you know how to calculate crystal field stabilization energy, that is equal to formula minus 0.4 and number of electrons in T2G. So minus 0.4, how many electrons in T2G? There are 2, that means minus 0.8 delta O. Now this can be written as 8 into 10 to the power of minus 1 delta O. Therefore, answer will be option D, student. The right answer is option D. So is it clear, students? Ishri, which question you are asking me? Is it the present question or the previous question? You want explanation again for which question? Is it for the present one? Or are you asking for the previous question? Okay, this question. See, the total difference is between this is delta O. The total energy difference between T2G and EG is delta O. which is nothing but crystal field stabilization energy. The question is, how much the energy is decreased by? If you see, these are the orbital where the energy is less, they are below, we have drawn below, whereas these orbitals are those which are above the d orbital, that means their energy is more. So if you see, the energy will be decreased by this much amount and the energy will be increased by this much amount. Since the question is asked about this part, how much the energy is decreased, you have the formula minus 0.4 into how many electrons in T2G. If the question would have been asked for increase, then you have plus 0.6 and how many electrons present in EG, isn't it? Okay, so that is how we are going to solve the question. Okay, so we'll go to the next one. Question number 26. Among the complexes Ni listed below, the following is the correct statement. So 15 Comet K exam, it has been asked NiCO4, NiCN4 2 minus, NiCl4 2 minus. And you can see the options have given geometry of the compound. So what kind of a geometry is shown? So instead of going with this option, quickly let us find out the geometry for these complexes. Once we find the geometry, student, our answer will be ready. So first we will go for NiCO4, nickel tetracarbonyl. You know the configuration 3D8 4S2. Now when I say 3D8 4S2, here nickel is in zero oxidation state because carbonyl is a neutral ligand. Carbonyl is a neutral ligand. So oxidation state of nickel is 0. That means 3D8 4S2. So you know 1, 2, 3, 4, 5 and the 4S. Okay, and the 4S. So this is 3D and this is 4S. You know there are 1, 2, 3, 4, 5 and you have 6, 7, 8. 3D8 and you have 4S2. When the carbonyl ligand comes closer to nickel, carbonyl is a strong ligand. So whatever electron in the 4S jumps back to 3D and gets paired with the 3D electron. These will come and pair with the 3D electron. As a result, the 4S orbital now becomes empty. You know after 4S we have 4p, isn't it? So you have 4S and you have 4p. Agree? Now the number of hybrid orbitals formed are 4 because you can see the number, and 4 empty orbitals will form a hybridization. So which are the empty orbitals, student? It is 4s and the 3 4p orbital. So the hybridization should be sp3. So when nickel tetracarbonyl has sp3 hybridization, its shape is tetrahedral. We all know sp3 hybridization means tetrahedral geometry. Go for the next one, NiCN4 2 minus. Students similarly try to find out now NiCN4 2 minus. Now when I say NiCN4 2 minus, it is 3D8. Why it is 3D8? Because nickel is in +2 state here. So 2 electrons are removed, so it is 3D8. That means you are having 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. When the strong ligand comes closer to the nickel, this electron will pair up. So how many empty orbitals should hybridize? The number is given. How many? 4. So here you have an empty orbital and that is D, and the next one will be S, and the next one will be the 2p orbital. So what will be the hybridization? DsP2 hybridization. That means this has square planar geometry. This is square planar. Go for the next one. NiCl4 2 minus. NiCl4 2 minus. So very clear, student, when I say NiCl4 2 minus, nickel is in +2 state, that means 3d8. But then students, you know that Cl4 or chloride or a chloroligand is a weak ligand. The unpaired electron will not pair. So only possibilities S and the p orbital should undergo hybridization. Therefore, it is sp3 hybridization. So it is a tetrahedral. So you can tell me the option 1 and 3 are tetrahedral and 2 has a square planar geometry. So answer is, students, option B. Okay, I hope it is clear. Okay. Now go to the next question. The formula for sodium trioxalato aluminate 3 is. Students, find out and tell me which one will be the right option. Is it option A? Is it option B? Or is it option C? Or whether option D? You have to write the formula for sodium trioxalato aluminate 3. So what do you think is the right answer? Whenever such question comes, student, you simply write like this: sodium. Okay. Then trioxalato, that means you have oxalato ligand 3. Aluminate, okay, Al. You have written like this. Oxidation state of Al is given +3. You know this is C2O4 ligand. C2O4 ligand means oxalato ligand. Each ligand valence is -2. There are 3, -6. That means sodium should give +3. So how many sodium should be possible here? Na3. So what is the formula? Na3 AlC2O4 3. That means answer is option, which one? C, isn't it? Option C will be the answer. You can see here 3 is written outside, so carefully you should find out. And C2O4 3 times, not even aluminium. This cannot be. So answer is only option C. Okay, go to the next one. The color of potassium permanganate is due to. In coordination compound, we also study about color of coordination compound. So you can tell me why potassium permanganate is colored. Because in case of coordination compound, whenever we refer it to color, color is due to the presence of unpaired electron. Color is generally due to the presence of unpaired electron. And you know that if there are ligands, the d orbital will split into T2g and Eg. And if there are unpaired electron, they will absorb energy from the light and they will undergo transition, and this transition is responsible for color. We know that the DD transition of electron from lower d orbital to the higher d orbital is responsible for coloration in complexes. We know that reason. But carefully see the question here. The color of potassium permanganate is due to. Okay. the color of potassium permanganate is due to? Is it due to DD transition? No, student. In case of potassium permanganate, it is not due to DD transition. In potassium permanganate, the charge is transferred from the O2 minus ligand to the manganese, to Mn. There is ligand to metal. This is ligand, this is metal. Charge transfer takes place. Due to this charge transfer, student, the photon, photon will promote an electron from the ligand orbital to the empty orbital of metal. In case of potassium permanganate is purple in color. The reason is, in potassium permanganate, the charge is transferred from the ligand oxido to the metal manganese. Therefore, answer is ligand metal charge transfer transition and not the usual transition. Are you getting it? Not the usual DD transition of electron. So you have to remember certain different options also, because when it comes to potassium permanganate, it is ligand metal charge transfer transition. This manganese has empty orbital. To that empty orbital, the ligand O2 minus is transferring the charge. That is why the coloration is seen. Okay, simple question. I am expecting answer from your side. Asked in pre-medical tests, you can see 2015 it is asked. Magnetic moment 2.84 is given by. Students, I have been giving these kind of questions to you. So when I say 2.84 magneton, students, I need to get square root of 8, right? Because I know square root of 9 is 3, correct? So if I want to get 2.84, I need to get square root of 8. That means my n value should be 2. Then only I will get 4 into 2, 8. So number of unpaired electrons should be 2. So in which option you will get number of unpaired electron as 2? Magnetic moment 2.84 is given by. In which option you will see as 2? Titanium 3 plus. Scandium titanium. Titanium is what? 3d2, 4s2. So remove 3 electron, that means it is 3d1 system, 1 unpaired electron. Chromium 2 plus. Chromium is 3d5, 4s1. If you remove 2 electron, you are going to get 4 unpaired electron. CO2 plus. CO means 3d7, 4s2. You remove 2 electron, that means 3d7. 3d7 means Hund's rule, each orbital will have 5 electron first and then the pairing. So number of unpaired electrons are 3. Okay. Ni2 plus. So if I say Ni2 plus, it is 3d8, 4s2. So 2 electron if you remove, it is 3d8. That means 1, 2, 3, 4, 5, 6, 7. Let me add one more here, 8. That means number of unpaired electrons are 2. So answer is Ni2 plus, option D. Correct, student? Okay. Go to the next one. Which of the following statement about COCN6 3- is true? Students, they are asking, you have to find a true statement for COCN6 3-. Okay. Now when I say COCN6 3-, what can be the correct statement? How many unpaired electrons are present? See, in the answer they have given two options. One is the information related to number of unpaired electron and whether it is a low spin configuration or is it a high spin configuration. So instead of struggling, directly we will find out whether it is a high spin or a low spin and whether it contains or does it contain any unpaired electron. So in this, first of all, you find out the oxidation state here, and it is very clear cobalt is in a +3 state or a 3+ state. So you know 3d7, it is 4s2. I am going to remove 2 and 1 from here, that means 3d6. So we will have 5d orbital, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 and 6. So how many unpaired electrons, students? There are 4 unpaired electrons. So very clear, student, very clear here that it looks like 4 unpaired electrons. So what happens is most of the time we immediately jump to a conclusion and say that there are 4 unpaired electrons. But then it is very essential that you look at the ligand. And it's very clear that the ligand is a strong ligand. And when it is a strong ligand, you know the unpaired electron pair. So there are no unpaired electron. So there are no unpaired electron. That means you are going to get, student, a condition like this, isn't it? Look here now. 1, 2, 3, 4, 5. So you have these two are paired, these two are paired. So no unpaired electron and all the electrons are paired up. That means the spin will cancel. One is spin up and the other one is spin down. Spin up, spin down. Spin up, spin down. That means all the spin is getting cancelled with each other. It's a low spin complex. So option will be option D, no unpaired electron, and will be a low spin configuration, student. I hope it is clear. So answer is option D. Okay. So students, we have been solving questions on this point, that is crystal field stabilization energy. Since I have been solved already questions related to this part, I am expecting answer from your side for this question. So kindly go through it. Among the following complexes, the one which shows zero crystal field stabilization energy. So which one shows a zero crystal field stabilization energy? Okay, so formula you know, CFSE, crystal field stabilization energy, is minus 0.4 into number of electrons in T2G plus 0.6 into number of electrons in EG. Okay. Now among the given option, which one is the right one? First one is Mn2 plus. Correct, student? Mn2 plus. So when you say Mn2 plus, the configuration is 3d5, isn't it? 3d5. So you will have 3 electrons in T2G and 2 electrons in EG, isn't it? So this will be T2G3, EG2. Okay, it is given 3 plus, not 2 plus, student. It is 3 plus, kindly see. That means T2G3 and EG1, and here you have 3D4. So you will have minus 0.4 into, students, you can see here, into number of electron is 3 plus 0.6 and number of electrons in EG is 1, student. Okay. So Can this be 0 minus 1.2? This is plus 0.6. No, you are going to get some value. So we need not check this one. We will go for the second one, Fe3 plus. Now when I say Fe3 plus, you have 3d6, 4s2. I will remove 2 and 1 from here. That means 3d5. So now it is T2G3 Eg2. Student, first of all, you should know why it is T2G3 Eg2. That is because this is a strong ligand, right? Electron, in water, when you have H2O as a ligand, electron will not pair. Rather, electron will jump to the higher energy orbital. Okay? So, it will be minus 0.4 into 3 plus 0.6 into 2. So, you have minus 1.2 plus 1.2. That means crystal field stabilization energy is 0. Okay. When water is a ligand, see student, d orbital splits as T2G and Eg. When I have 5 electron, I am going to keep 3 here and not the pairing here. Understood? I am not going to do the pairing here. Rather, I am going to keep the 2 electrons in Eg. Why? Because water is not a strong ligand. It's not a very strong ligand. Therefore, electrons will not pair. Rather, they will go to the higher energy orbital. So, the possible answer is option B. So, students, I have crossed my time. So, my next YouTube session will be on 24th, exactly at 2 o'clock. If you like my class, kindly do not forget to press the like button and share these videos among your friends. Do not forget to subscribe the YouTube channel also, and if you haven't watched my classes, kindly watch the previous YouTube classes also. Thank you students. Keep studying and keep preparing for the competitive level exam. Be focused and think that every minute you are moving towards your competitive level exam. So bye students, take care, and we will see you soon on 24th exactly at 2 p.m. Bye students.